In this video, we're going to talk about organizing classes, chapter 1.2, and we're going to briefly mention exceptions in 1.3. So it's combining 1.2, 1.3 in this video. So let's move on to that section. So if you haven't reviewed 1.1, the video is available before this. So we talked about classes, objects, and application. Let's talk about how we kind of organize them. So as I alluded to in my previous video, we talked about the is-A, right, and also the has-A relationship that make up for the the organizational structure of any software applications. The task of keeping track of these classes would be impossible without these organizational structures. Let's start up with the is-A relationship. And this is the classical inheritances and principles in an object-oriented programming programs. So two of the most important ways of organizing Java classes. One is the inheritance, and the other one is packages. Even though we're not going to make use of any packages in this course, because most of the problems that you are required to solve should not have your own personal package in there, and because we're not doing a project or class project in general, such that you're going to have multiple utilities sitting inside of libraries where it's much easier to package them. But we're still going to talk about the idea of what a package is. But most of the most important part is to make sure that you understand what an inheritance is in Java, so that you can move on with the data structure aspect of this course without any issue understanding how these codes are constructed in general. So let's move on to the inheritance part. So Java does not have what's called multiple inheritance. What you see here is single inheritance, starting from the top, where you have this linear family trees where one single parent gives kind of birth to the offspring one at a time. In C++, you would have something like this, where one class could be inherited from like multiple parents and something like that. And that becomes an issue because this creates what's called the classic diamond structures, where you have a class inheriting off of multiple paths. And at the end, it's super confusing as to where this. So when I say at the end, it's basically the very last class. Let's say class C here. You don't know, first of all, if this class C inherits structures mostly coming from the left or right. Like, is it coming from here or is it coming from here? Like, where is C's information and attribute coming from? Is it coming from this path or coming from this path, right? You don't know. So Java got rid of these multiple inheritance paradigms and said, hey, you can't do that anymore. So in order for you to inherit from another class, you can only do it once using the extends keywords. So extends keyword does not allow you to, for example, if you have a date class and you would want this date class to be inherit off of another class called spring or fall or summer, you cannot do this in Java. And this creates what's called multiple inheritance. So you can only do it once. However, Java gives you the ability to implement interfaces. So we talked about interfaces in the first week or second weeks rather, and you can have a class instead of extending another class. You can implement. In this case, interface 1, interface 2, so on and so forth. Okay, so this Java allows you to implement multiple interfaces, and for an interface, you can actually have interface extending from another interface, but this kind of goes beyond the interface in classes in general. We're talking about the general inheritances as well. We have one class inheriting off of the other, and the parent class is typically what we call superclass. Sometimes in different textbooks, you hear people talking about parents, and the child class in this case sometimes is referred to as either a subclass or child class. Anyway, so there are different terminologies, but they're all synonymous to each other. And if you know these Just make sure that you when you read the textbook that you understand what the author was saying by referring to these terminologies. So this inheritance allows programmers to create new class that is specialization of existing class. So generally speaking, we use inheritance to create either a specialization sort of thing, meaning your subclass is a more specialized version of the class. But also there's other type of use cases where you're extending the use of your base class. But anyhow, so this is just a different way of kind of thinking your software design. This is not a software design class, but if you ever take that class, you'll actually gain a lot of these information. It's quite philosophical, but philosophical in the sense that it is good because you can actually put things in perspective and implement your software application a lot more efficiently, with a well-designed and thought out, component ahead of the implementations. So this is inheritance on a very high level. Let's move on to the next page. This is an example of inheritances where you have your increment date, INC date, inheriting off of your date. So this date was from the previous slide. Again, this is the author package. We don't concern about this. So this in date is a public inheritance here, inheriting off of this date. This in date has its own constructors here that calls also the super. So super is your super classes. So in this case, when creating an instance of your inc date object, you're also supplying the information that you get from the three arguments into the superclass or the date object. So the date object generically has this info to power the toString part. If you recall, there was a toString there. So in addition to the list of methods in your generic parent class, you also have your own custom methods that is available only with the increment date. So this increment increments the date that you just received by 1 day. So if your argument passing in is 6/30 2005, this adds one more date that takes you to 7/1/2005. So this is the implementation algorithm, which is not shown here. We're just showing the high level. So let's move on to the next slide. Declarations of dates in objects. So we're dynamically creating, instantiating two date objects. One is your generic date, and notice that this is your superclass, and this is your child class. So what's interesting is because InDate inherits from your date object. So when you create this InDate object, what you're creating is this a day, but also another instance of a date. So there's actually two objects created here on the second line. And obviously the very first line here only has one date. So in order for InDate object to work fully, there needs to be this date superclass. If you recall, in the constructor of InDate, you're passing in the three values into the super. So this creates the parent object. So anyhow, when you do myDay getDay, you're getting the day that is from. So this a day, because this a day, which is part of the InDate, does not have that implementation. It's getting this getDay directly from the parents class. So what this means is that your increment date object has access to the parents method as well. So this is not polymorphism. This is just a pretty straightforward use of your reference variables and calling the reference variable with the methods that you're trying to invoke. In this case, this is a relationship. So a day is a date, which means that a days has inherited this get day information from the date object. So what is the kind of the significance of this? Well, if you don't have this inheritance paradigm or principles in OOP, like OOP does not allow you to inherit one from the other, then what you're basically having is a lot of duplicate codes. For example, this get day implementation would have to be available inside the int day, but because you're inheriting the structures at runtime, and if you've taken C++ before, this relationship is made available through virtual table, this memory function table at runtime, and Java does not have that, but it is essentially written in C++ or the compiler itself. So there is a notion of this memory linkage, and that's what makes OOP so powerful, because you don't have you don't ever have to duplicate so much code anymore. A-day increment obviously calls the increment date increment method, which you saw in the previous slides, and then you're printing out basically what the date is. So the extended class diagram in the next slide shows kind of the organization of this. So let's move on to the next one. And as you can see that the my day and the a day, but because when you instantiate it in day, this in day has a notion of what this date is. There is actually an object created for this, and dynamically allowing you to link them together, into a bytecode that could be run by your Java runtime virtual machines. Okay, we're not going to spend too much time on this object diagram here, but let's move on to the crux of the inheritance tree. So, like I said before, Java supports single inheritance only. There's no multiple inheritance. Method calls are resolved. So this resolution is dynamic binding. Okay, so it is not a compile time decision. It's what they call late binding decision. In this case, there's not much of polymorphism involved. Simply inheritance, allowing you to trace that tree, basically what that reference is referring to, through the memory tree to get to the destination where the method calls are found, so that they can be invoked. So all the Java classes can be traced up to the object classes. Like I said before, java.len.object is the kind of the source of truth for all of the objects created in Java. And then you also saw this notion add override. So this notion is responsible for overriding the behavior of of any of the methods from the parent. In this case, it could be the object, it could be the date. When you overwrite the method in the subclass essentially just takes over the entire implementations. And this is a very useful features too. So you don't always have to rely on your parents to give instructions. The child classes has the freedom to basically refactor or re-implement the logic. Okay, all right. Inheritance based on polymorphism. So this is, like I said, dynamic binding, and it depends on what this object was pointing to, statically. So when you're in your class designs, you specify which object that you're extending, and then whichever object that you extend becomes the parent class. So polymorphism in a general sense means many faces. So poly means many, right? And morphism, so this Greek word in the contemporary English, it means phase. So having the ability to change shapes and forms and sizes is what this polymorphism means. So what you can do is you can create polymorphisms, and again, we're going beyond inheritance, right? This is the ability for an object to change its size and shapes and forms depending on this other references that it is pointing to. So lots of times you can have something like this. Let's say if you want to create a shape class, and this shape class equals to a new circle. So circle is a type of shape, but in this case, I see I mistyped it. Okay, so in this case, what you're doing is assuming, right? Again, this this is high level. So assuming the shape is the parents of your circle, right? So you can have something like this, and this becomes very important because the the type of an object that this S points to is actually determined by the dynamic memory address that is being assigned to at runtime. And this dynamic memory address that's being assigned to at runtime is through this new keywords. And this becomes, so S becomes a type of shape, but it is a circle. In a sense, it has access to circle, but also has access to shape, but it depends on the situation still. And also various different encapsulations that you set, making certain properties available and certain other properties are not available. You can have various different access capabilities and data accessibilities. A variable declared to be of type T can hold a reference to an object of type T of any descendants of T. So T is a Java 1.6 plus concept. It's what we call generics. So when you see T here, it is referencing a type, a generic type. That could be an integer, that could be a string, could be a Boolean, so on and so forth. So this is a very, very powerful inheritance type of paradigm that becomes available in recent decades or so in many, many different languages too, not just Java. You see this in Golang, you see it in C++, and so on and so forth. Okay, let's move on to the next slide. So this illustrates I guess, inheritance-based polymorphism. So we're starting off with an instance of an object. So this object is instantiated off of stack. This is not off of heap, okay? So you have this object, and this object it depends on really what the cutoff is. So in this case, this cutoff is responsible for routing the creation of this object either to this path or this other path. Essentially, when you're done creating it, because everything inherits off of the object, so what you can do is this is dynamic, this is polymorphism here. This polymorphism allows you to assign a object, either a string or date, to this OBJ, and it still works. And depends on what is being assigned to at runtime, becomes this toString will be associated with either from the string or date. Okay, so so this is dynamic binding we're talking about. If you really get into polymorphism, there's two types. One is the static polymorphism, and the other one is dynamic polymorphism. Static polymorphism is something like method override, something that could be determined, that is determined at compile time. But most of the time when we're dealing with polymorphism, it is done through dynamic binding, late binding. And this is kind of one of the many examples you'll see in polymorphism. Okay, so the reason why we're going through this is because once in a while you probably see something like this in data structure code. So just make sure that you're familiar with the concept of polymorphism. If you have any questions, you can kind of come ask me, or just try to freshen up yourself by going through some intro textbooks, and they'll talk about these things. Okay, so we're just going to briefly kind of talk about packages because we're not going to use much of it in this course. So packages are one of the many ways to organize your files. So what does that mean? Your files are your classes. So let's say if you were to create this package, say XYZ, and this is for you to use for the purpose CIS 20 or CS20B, then you can create a subfolder called utils, and everything that you do for this class that could be considered a util. So util could be a print facility, a string facility, or maybe a way of validating your code. Whatever these classes are, you put them all in the same folder, same structures. You can actually create a package that way. And Java allows for package level access. This becomes very important. This is one way to kind of group your code, but also making sure that when you create a package, that everything comes in the package can basically have access to each other's. And this makes kind of consolidating a package in a virtual sense, not utilities or functions that are of similar nature can be grouped together. So one example is Java util, right? Java util you see here. There's also Java IO. So anything that is input output could be in the same package. And that's how packages are used. You will see some of that in this course, especially when you have group data structures that making use of, let's say, IO or util, like collectibles and iterators. They're all coming from the same package. You can actually just import the decorations to make the contents of these packages available in those code. But other than that, you're not going to be creating solution using any of these packages, because if you do so, that would become ungradable for me. Okay, so that is packaging in a very high level too. Let's talk about, so we're going to bypass these things. You're going to see a lot of these import. I try to get rid of them in the sample code that I display but if you still see these things, you know what they are, okay? If you have a textbook, textbook has an online access. I think it's called Navigate 2 that has some of these codes available. But I am making these codes, these files available anyway. So you'll see them. But if you do see these package, they're not compilable because you don't have the entire libraries that user has, the author has. So just make sure that you comment those out. That way you can still compile these codes. All right, we're just gonna also touch very quickly on this exceptional situation. So this exceptional situation is really just exceptions in Java. So exceptions means errors. So when something happens, let's say if you have an empty stack and you're trying to pop an element off of an empty stack, you can't do that. If you're using Java util.stack, most likely you're gonna get empty stack exceptions. So it depends on what the situation is you can also have a array of 3 elements, and if you try to insert the 4th elements into this array, which only has 3 slots, you're gonna get array index out of bounds. So there's a couple of these exceptions that are pretty famous, pretty commonplace. So exceptional situation is for you to handle these cases, these use cases when the error happens. So exceptions in Java could be done either using the exceptions class. You can actually create your own custom exceptions. Let's say homework assignment 2 exception, assignment 3 exception. So you don't need to do that. Exception is just a means to preempt you from entering into a nasty situation, for example, code crash, or exiting the code prematurely before you're done with the execution. So having these provisions in place, allows you to gracefully handle the situation. And however you handle it is completely up to you. Either you can exit the code, or you can just simply print out the info to a log and then continue the executions nonetheless. But we're not doing any of that because this is not an advanced Java class. We're not going to go into the specific implementation details and making sure that you have these things. We care about data structure in this course. So for just to illustrate this is because you're going to see throw, you're going to see try and catch in different code snippets that I offer in this course. So you have to understand them, right? So in order to catch these exceptions, you use what's called try and catch, right? You try it and then you catch it. And whatever you caught, it depends on what it is you specify in the catch. It could be either generically an exception, or it could be a very specific exception like array index out of bound. Either that, or you can try to throw that exceptions back and said basically, hey, I see there's an issue here, but I don't want to handle that issue now. I want my caller, whoever, I mean, it could be maybe 3 or 4 levels deep in the stack. in terms of your execution. Your flow of control then is going to throw that error back to the caller one at a time. If the caller didn't have any provisions in place, you'll basically throw back into its own predecessors. So the flow of control eventually goes back. It's kind of like back tracing. Eventually somebody's going to have to capture it. If not, then when it goes all the way up and bubble all the way up to your main, your main is going to basically say, hey, I don't know what to do with this, co-exit. So that happens a lot of times, but trust that if there's a need for exception handling in any of the solutions that you need to deliver, I'll let you know. Mostly not. I would tell you for this solutions, you don't need to handle this specific case because it is assumed. You're going to see constraints and assumptions for these solutions where there's no chance for an exception to happen. But whether you want to handle your exceptions or not, just being very, very thorough, it's completely up to you. Okay, so that was exception. So this is kind of an example of abstract data types, exceptions. You'll see something like this: date, out of bounds, exception, extends exception. So this is a custom exception that the author just created based off of a generic exception Java class. And the use of this is to make sure that these things are caught with a specific mechanisms in place. And this exception takes a message and simply outputs the message. This message is sent to the exceptions class, which does something to this message, which I think is just printing it to the console. Okay, and then you're gonna see lots of this too. So throw new date, basically say, I don't wanna handle this right now. I'm gonna throw back to the previous caller. So generating, raising the exception by recognizing the exceptional situation and then raising. I don't know why they call it exceptional situation. It's actually exceptions, right? This is what we talk about. And then using Java's throw statement to announce that the exception has occurred. So that is kind of the one of the ways you can deal with the exception. So you're gonna see stuff like this throughout the remaining part of this class, where you see custom exceptions thrown here and there. Don't worry too much about it. Just make sure that you understand the principle behind what this is in place. So I'm not going to ask you to write codes like these. This is not conducive to how you make use of data structures, in my opinion. So that is that. Here's a couple of more. So I would strongly advise you to understand what exceptions is. You don't have to go super deep into it. Just know that you can kind of navigate through the different implementation of these things. So this is one example where you see throws. So there's a difference between throw and throws. Okay, so throws basically says exceptions out to the interpreter. So interpreter is your Java virtual machines. You can do that also on a lower level too. It propagates these exceptions back through the stack into the callers. So somebody eventually is going to have to do it. And the other one is more about the announcement of that exceptions, and you'll see those things. Okay, so that is pretty much it. At some point, somebody's going to have to try and catch, right? The lower divisions announces the informations and you catch it. Or you can say, I don't want to catch it. I'm going to throw it back. In that case, the interpreter, in this case, will then eat up this exception and give you some pretty nasty error message. And that nasty error message is what you just defined right here. Okay, whatever you just entered. Okay, so I believe this is the exception portion of, yeah, and there's some best practices here and there. Again, if you don't know what this exception thing is just make sure that you go through, 20%, 30%, even 50% of what this is on a very, very high level. You should be sufficient. It should be sufficient for this course. Okay, so here are the exception situations and various different associated with various different abstract data types. So abstract data types are data structures. So you're going to see stuff like this. Detect and handle the error within the method itself, detect the errors within the method, but throw an exception related to error and force the calling method to deal with the exceptions. Or you can see that at some point, the entire error condition is completely ignored. With this approach, the preconditions of a method are not met. The method is not responsible for the consequences, and things like that. So we're going to run into these various different situations throughout the semesters. If you have specific questions about these things, you can ask them, but it should be pretty straightforward in my opinion. And these code snippets will be made available per the ADT each week. Okay, so this completes our lectures on both the class organization as well as the exceptions.